Now let's look at how X-rays are produced. We already looked at in the first lesson on modern physics. We looked at cathode rays. We also looked at X-rays, the definition and the properties of X-rays. Now we are looking at production of X-rays. How are X-rays produced? Now X-rays are produced in a machine called an X-ray tube. As we have stated here, that X-rays are produced in an X-ray tube. So how does an X-ray tube look like? We shall look at that later, but let's first look at this question. Briefly describe how X-rays are produced. Briefly describe. That means you may not need the diagram of an X-ray tube, but briefly tell us. You can see even the marks are just a few. Briefly. So how are X-rays produced? Some time back when we were handling cathode rays in one of our previous lessons, we said cathode rays are used to produce X-rays. So there is no way you can produce X-rays without cathode rays. So you first produce the cathode rays. So the first thing is cathode rays are produced from a hot cathode. From a hot cathode by thermionic emission. So the first thing is you heat the cathode. The cathode is a metal, and we said metals have free electrons. So once you heat the cathode, time comes when the cathode will release electrons, and that process is called thermionic emission. So there's no way you can produce X-rays before producing cathode rays. So the first statement is tell us how the whole thing. First thing is first. Cathode rays must be produced first. So cathode rays are produced from a hot cathode by thermionic emission. Now what happens to the cathode rays? These cathode rays, which are the fast moving electrons, strike a metal target. And once they strike a metal target, as a result, what happens? X-rays are produced. So that is being very brief, as the question says. Briefly, cathode rays are produced from a hot cathode by thermionic emission. After that, what happens to the cathode rays? The cathode rays now strike a metal target, and as a result, X-rays are produced. Okay, that is being brief. What about if they said, describe how X-rays, supposing this examiner had said, describe how X-rays are produced in an X-ray tube. That means you need to draw the diagram of an X-ray tube. So let's first understand. Draw a well-labeled diagram. Draw, that is C Roman 1 question. Draw a well-labeled diagram of an X-ray tube. 6 marks. So you first need to know how an X-ray tube looks like and what are the major parts. Now let's look at the X-ray tube. So the X-ray tube looks like this. You see, here you have high voltage. You see, here you have a high voltage. Okay, then here you have tungsten metal target. Actually, the whole of this is called the anode. The whole of this, you see, but is made out of copper. So we call it the copper anode. Then here, they will put here, these lines here, those are fins. We call them cooling fins. So you have the copper anode, you have the cooling fins. Then, in front of the copper anode, there's a metal target. You see, this is a metal target, but it's made out of, the metal is called tungsten. So we call it tungsten metal target. Then what you see in the form of dots, what you see in the form of dots, these ones, those are electrons. So we call them electron beam. Then in front of the electron beam, you have the filament. You can call it the filament or you call it a filament cathode because it is the cathode. Okay? So you have the filament cathode. Then this side you have low voltage. This is a rheostat to control the amount of current. This is an ammeter. to measure the amount of current. Then here you have low AC voltage. AC means alternating current. So we use alternating current here, but it should be low. The voltage should be low. So low AC voltage. Now this low AC voltage is the one which is connected to the cathode. Remember, the work of the cathode is to produce electrons once it is heated. Now what is heating the cathode here? It is the low AC voltage. So the work of the low AC voltage is to heat the cathode such that the cathode produces electrons. Now these electrons, once they are produced, you see, these are electron beams. They go to the what? To the anode side. But now they will not meet the anode, they will meet the tungsten metal target. What did we say? How are X-rays produced? We said X-rays are produced by first of all producing what? Cathode rays. So how do you produce the cathode rays? The low voltage hits the cathode, then the cathode produces what? Electrons. Then those electrons move from the cathode, they go towards the anode. Now for them to move here very fast, you need high voltage. Are you seeing high voltage there? So the work of the high voltage, is to increase, to accelerate the speed of the electrons. Remember, we said cathode rays are fast moving electrons. So once these electrons are moved, they are produced from here, they must move very fast. So that is the work of the high voltage, to make sure that it accelerates them across the vacuum. Because inside, you see this round thing, we call it the glass envelope. Inside that glass envelope, there should be a what? A vacuum. We don't need any air here. Why don't we need air? Because air is going to interfere with the movement of these electrons. Once these electrons are produced from the cathode, they should be accelerated. They should move very fast, and that is the work of the high what? High voltage. Okay? So as the electrons move very fast, they go and strike the metal target. And as a result, are you seeing these straight lines? We say the X-rays move in straight lines. So these straight things which are produced are called what? X-rays. So another thing which is, another feature which is near the what? The cathode here is this one. We call it the focusing cap. I think it is the one helping the cathode to direct these electrons so that they are straight with what? They are straight with the metal target. Because once they leave here, their speed should be increased by high voltage. They go and strike the metal target, and then X-rays are produced. So the main parts are, we have the copper anode. Why is the anode made out of copper? Because copper is a good conductor of heat. Because copper is a good conductor of heat. Why is the tungsten made out of, why is the metal target made out of tungsten? Because tungsten has a very high melting point. So these are the main parts of the X-ray tube. Now let us explain how it works. Explain how X-ray tube works. 4 marks. So as we saw, the cathode must be heated by the low voltage first. So the cathode is heated using a low voltage AC supply. Once the cathode is heated, what happens? The cathode now produces or emits electrons by thermionic emission. What happens to those electrons? They must be accelerated. The electrons are accelerated to the anode by what? By high voltage. Now, as they go towards the anode, as the electrons are moving at a high speed, those are cathode rays. As cathode rays strike the metal target, 99% of their kinetic energy is converted into heat. You see? So the metal target becomes very hot. 99% of the kinetic energy of the electrons turns into what? Cathode rays turns into heat. And then 1% turns into X-rays.